Okay, for the questions, the first example that you have, it's a direct substitution of numbers. So I will just add the final answer for the R that you need, which is 382 milligram per day. Okay, and the second question, we have 6.5 km milligram per liter. We have Vmax, that is equal to 548 milligram per day. Okay, and what would be the question is about the steady state concentration for a rating dose and milligram per day of 100, 200, 300, 400, and 450 milligram per day. Okay, the idea of this question is not that to calculate how to calculate this, because you have the daily dose equation and you have it on the same slide of your question, and if you rearrange it, you will have the equation of the steady state concentration, and you will have both of them in your equation sheet, inshallah. But the idea is just to see the difference of the concentration, steady state concentration, if we are talking about nonlinear kinetic. We mentioned that steady state concentration for with the dose taken, which would be similar to this, would be like this for linear kinetic. But we said that it will deviate from linearity if we're talking about nonlinear kinetic. If you go and substitute the numbers in the equation of the steady state, you will find that it's for 203.73 milligram per liter. You will have it. This is for 200. This is 1.45. This is 7.86, 17.6, and for 450 it will be 29.84 milligram per liter. Okay, if you notice that if we have this and we increase it by twofold, if you remember before when we had the linear kinetic, if increasing the R twofold, it should increase the steady state concentration smooth. Okay, it will be two-fold, the concentration will increase by twofold. If it's threefold, it will be increasing by threefolds. Okay, but whatever is happening here is not. Just try to multiply this with 2, multiply this with 3, multiply this with 4, and you will find it's not, and it's will be almost near the number that you have at the beginning, but as the concentration increases, you will have it as this. And again, at and if you go and to do the graph, just do a sketch for that, or just use your Excel sheet to see the graph, you'll find it that it will be something like this. Okay, steady state versus the rating dose that you have of your drug. Okay, for the time to reach the steady state, again, it's not the idea of how to measure it, because it's just a direct substitution, and the question that you will have in your exam will be similar to this. So for your third example, you will have different doses, okay, per day. We have 200, we have 300, and we have 400. As time to reach the steady state final answers is in days, it's equal to 1.33, 2.16, 4.41, and 15.8. And again, increasing R, it means that Vmax minus R squared in your equation will be decreased. So accordingly, time to reach the 90% of the steady state concentration is increasing. Okay, that's it for this question. Then after that, those are the questions that I will do with you, or I will walk you through them. A patient achieved a steady state concentration, trough concentration of 9 milligram per liter, receiving milligram per day of phenytoin, and then when the daily dose was increased to 400, so this will be 1 and this will be 1, daily dose increased to 400 milligram per day, the steady state concentration, which I call it 2, it's equal to 16 milligram per liter. Then he's asking to determine Km and Vmax. First of all, if I didn't give you those and you have R, or the daily dose, in this case it's milligram per day, versus a steady state concentration R over steady state concentration, and you have this profile and it give you a linear regression equation. As I said, it will be something like, right, equals y, and it will be decreasing, so it will be equal to something like this, which is this. Okay, so by default you will know that this will be your Vmax and this will be your minus Km, right? Just make sure before anything that this is R over a steady state concentration, not R, and this is R, not anything else, not V, for example. Okay, so if I give you the equation, you will be able to determine it directly. Okay, if not, and asked you to determine it visually, you can determine this visually, right? And it's from the graph that you have in your slide, Vmax visually. This is if I give you the equation graphically using the graph. By the way, there is some student asked me, what do you mean by graphically? I was shocked, not because of the question itself, but because we already explained this in the first exam, the first exam material. Okay, so graphically using the graph, okay, Vmax from the slide that you have is 700 milligram per day. Okay, if you have Vmax, one of the parameters, you can go back, either we said, to this equation or to Michaelis-Menten equation that you have. So either you go to this V equals Vmax, or to the Michaelis-Menten equation that you have already, so steady state plus Km. And you use one of those. You either use, let's say, the first one, 9, I need this is 700, okay, and this is R, which will be equal to 300, okay, and you go and do it, okay. Otherwise, I may just give you this and ask you without this to determine Km and Vmax. What you will do in this case, you will try to determine the slope without, I didn't give you the linear regression. I didn't give you all data. You just have two of them. Okay, so you can't do linear regression by yourself. You don't have the graph to determine it. Then you will use the math way to determine it by knowing from the explanation of this chapter that minus Km equals the slope, right? The slope of the profile that you have. You have 2 points, then you know that the slope will be delta y over delta x, which will be equal to R2 minus R1, R2 over steady state 2 minus R1 over steady state 1, okay, which will be equal to 400 minus 300, make sure that you substitute numbers right, 300 over this is 9, and this is, sorry, this is 16, and this is 9. Okay, and you will, this will be equal minus 12. So Km will be equal to 12, and the unit of it will be the same as the unit of the concentration, 12 milligram per liter. How we determine this? How I can determine this? Again, as I said, either you substitute it in this equation or Michaelis-Menten equation. Just let's do it like this to have the numbers here. So you either go and say R equal steady state concentration Vmax over Km plus steady state concentration. And again, if you use this, this should be 1. If you use 2, this should be 2. This is what you want. This is 12. This is 9. This is 9. And this will be 300. And again, the answers should be for Vmax is the same. Either you use those data or those data. Okay, data points. Okay, Vmax will be equal to 700 milligram per day. Okay, for this is the last one. No, you have the fourth question is it just a bit, 1 second. If you have, we did this and we did this. And for the fourth question, if you ask to increase the steady state plasma concentration to 200, 1 second. Okay. If you ask to increase the steady state plasma concentration to 20 milligram per liter, the second measured was 16. Let's say the physician needed to be higher 20. What would be the necessary R to determine it or to achieve that concentration? Again, you have Km, it won't change. You have Vmax, and it won't change. You have steady state concentration, so you need R. This is follow or the continuation of question number 4. So accordingly, R will be equal to your Vmax plus or multiplied to steady state plus Km. Again, you have this as 20, the new concentration. This is 20, this is 700, this is as 12. So you can determine this, and you have it as 437.5 milligram per day. Okay, and by this we finished everything, alhamdulillah, and inshallah we will see you بخير وسلامة inshallah. All the best. Assalamu alaikum.